If you're a Jupiter lover and a stargazer, then you probably observed Europa, one of Jupiter's Galilean moons. And you probably wondered if humans ever visited this moon, or at least sent a spacecraft. Well, you're in luck, because soon a spacecraft will indeed visit Europa. We appreciate NASA's finally dedicating a special mission to discover Jupiter's icy and cold moon Europa. If you're not familiar with Europa from stargazing nights, at least you might have seen it in one of NASA's spectacular photos. Even though no past missions have been especially dedicated to visiting Europa, a few missions did in fact fly past it or observe it up close. These missions are Pioneer 10 and Pioneer 11, Voyager 1 and Voyager 2, and the most recent is the Galileo spacecraft that launched back in 1989. In addition to these past missions, NASA constantly monitors Europa using the Hubble Space Telescope that observed evidence for water plumes on the moon back in 2012. But if we can already study Europa using past flybys and the Hubble Space Telescope, then why do we need a special mission to go there? That's a very good question. Studying Europa up close serves one of NASA's and humanity's biggest long-term goals, which is searching for extraterrestrial life. Now, you might think searching for life outside Earth means going off to a faraway galaxy and exploring planets thousands of light years away. And while that possibility is taken under consideration, we must also not neglect the vast possibilities of extraterrestrial life inside our own solar system. And what better place to start looking than a moon that's speculatively rich in subsurface salty water with a thin oxygen atmosphere? Europa falls under the classification ocean world, and that's because past missions have suggested the existence of oceans underneath the moon's icy crust. Oceans so vast their volume is estimated to be around 3 billion cubic kilometers. That's more than double the volume of Earth's oceans. And in expression of the importance of further discovering Europa, Thomas Zurbuchen, Associate Administrator for the Science Mission Directorate at NASA headquarters, said, "We are all excited about the decision that moves the Europa Clipper mission one key step closer to unlocking the mysteries of this ocean world." Now that we have discussed why we must further study Europa, and you're hopefully convinced with the reasons presented, let's start talking about the mission. The mission is called Europa Clipper, and it's a collaboration between NASA and the Jet Propulsion Laboratory in Caltech and the Applied Physics Laboratory at Johns Hopkins University. Europa Clipper is designed as an orbiter to perform multiple flybys of Europa to comprehensively study all areas of the moon. The spacecraft will be 6 meters, approximately 20 feet high, with huge solar panels measuring 22 meters, 72 feet across. And to talk back to Earth, Europa Clipper will be equipped with a 3-meter, approximately 10-foot high gain antenna. Orbiting Jupiter once every 2 weeks, Europa Clipper will perform a total of about 45 close flybys. The spacecraft's altitude above Europa will vary from 25 kilometers, 15.5 miles, at the closest point to 2,700 kilometers, 1,677 miles at the farthest point. NASA is sending Europa Clipper to help scientists and astrobiologists answer big questions in science. Therefore, the mission has clear and concise scientific goals. 1. Determining the characteristics of the subsurface ocean alongside looking for water in the moon's outer shell and measuring its thickness. 2. Studying chemical components in Europa's atmosphere and their origin. 3. Measuring Europa's magnetic field and determining its various parameters. 4. Studying geological activities on the moon and its surface features and looking for suitable landing sites for possible future missions. 5. Investigating Europa's capabilities to host life as we know it on Earth, which provides progress into astrobiology. To tackle these goals, a wide range of scientific instruments are on board Europa Clipper. The mission has 9 various instruments to make sure scientists have all they need up there to do the science. We're going to talk about these instruments one by one. First, we have the e-THEMIS, which is short for Europa Thermal Emission Imaging System. As the name indicates, this instrument is going to take infrared images of Europa's surface by measuring the thermal emission from different areas of the Moon. In addition to that, the e-THEMIS instrument will also create a temperature profile of Europa's surface, which will help in identifying areas where warm ice might exist. Next, we have ICE, that stands for Europa Imaging System. This system carries two 8-megapixel color digital cameras. The cameras take images mainly in the visible light spectrum, but extend as well on both ends to catch a little bit of the infrared and ultraviolet spectrums. And since studying Europa's geological features and activities is one of the mission's goals, these two wide-angle and narrow-angle cameras will provide geologists with perfect high-resolution images that have never been taken before of the Moon's geology. Cynthia Phillips, a planetary geologist in NASA's Jet Propulsion Laboratory, said in a comment to the prospect of high-quality images of Europa, "We've only seen a very small part of Europa's surface at this resolution. Europa Clipper will increase that immensely." Furthermore, the advantage of high-resolution cameras will open the door to many scientific investigations, like knowing the Moon's surface material and its ice shell structure, and signs that support or deny the theory of observed plumes from the subsurface into space. Next instrument is Europa Clipper's Ultraviolet Spectograph, or Europa UVS for short, and this instrument will have the capabilities to capture light in the ultraviolet spectrum and analyze it in order to gain information on the composition and material found on Europa's surface and in its atmosphere. Europa Clipper will also be equipped with a magnetometer that will allow it to measure the Moon's magnetic field strength and confirm the existence of its subsurface ocean, as well as characterize how salty and deep the ocean is. Now, do you remember when we said that Europa has a thin atmosphere? That's probably because the atmosphere is constantly escaping the gravity of the Moon, and with the magnetometer on board Europa Clipper, scientists could finally shed some light into this mystery. On choosing the model and design of the magnetometer, NASA first went with an instrument called IceMag, short for Interior Characterization of Europa, using magnetometry, but the cost was extra high for the budget dedicated to the mission, so the administration had to find a replacement that's as good as IceMag but less expensive. However, that replacement is yet to be found. Also included in the suite of scientific instruments is a mass spectrometer called MASSPEX, which is short for Mass Spectrometer for Planetary Exploration. And just like any mass spectrometer, the MASSPEX will help in determining the mass of some chemical components. In our case, these chemical components are different gases in Europa's atmosphere, alongside hydrocarbons and other materials. The MASSPEX will also aid in studying how chemical components are affected by Jupiter's strong radiation. The mission is equipped with yet another spectrometer. This spectrometer, however, is not a mass spectrometer, rather an imaging one called the Mapping Imaging Spectrometer, or MISE for short, which operates in the infrared spectrum of light and therefore will capture infrared images of Europa's surface that will show details of surface composition and information about hot areas on the surface. The MISE will also go far and beyond to help answer questions about habitability in the subsurface ocean and dive into the history of geological activities on the Moon. The next instrument has to do with understanding the plasma, which is basically charged gases around the Moon Europa. Due to Jupiter's magnetic influence on Europa, the Moon is constantly bombarded with plasma from Jupiter and its moon Io and other extraterrestrial bodies. Therefore, the Plasma Instrument for Magnetic Sounding, or PIMS for short, was selected to be on board Europa Clipper to study parameters that have to do with the flow of plasma, like the density, velocity, and energy of the plasma, among others. The instrument will operate using 4 sensors given the name Faraday cups. An electrical current from the plasma will flow through each sensor, where it will be met with detectors that will analyze the current to extract the data scientists need about the flow of plasma. And because a radar is an orbiter's best friend, Europa Clipper also has a radar instrument called Radar for Europa Assessment and Sounding Ocean to Near Surface, or REASON for short. The radar uses waves in the high frequency HF and very high frequency VHF ranges to send signals as deep as 30 kilometers, 18.6 miles, into Europa's ice crust. The signals reflect off different layers of the crust and return back to detectors on the instrument, where they will be analyzed to figure out information about the structure and thickness of the ice crust. The radar will also benefit in studying Europa's surface and water plumes. The ninth and final instrument has to do with something you might find trivial, but is actually pretty important, which is dust. A lot of dust particles and dust-sized pieces are ejected from the surface of Europa into space due to small meteorite impacts on its surface. Dust-like particles are going to pass through grids inside the Surface Dust Analyzer, or SUDA for short, where they are going to be studied to get information about their speed, composition, and origin. Further data analysis on the dust might give scientists an idea of whether Europa can harbor life as we know it or not. I hope you noticed how more than one instrument is studying or investigating the same scientific questions. Such redundancy in the instruments is intentional by the science team so that the instruments would complement each other in case one of them failed to work or got faulted. Additionally, complementary instruments allow for data from one instrument to be easily validated using data from another instrument, which makes the science reproducible and more efficient. Designing scientific instruments to work properly in orbit around Europa is a challenging task. That's because all payloads and scientific instruments on board Europa Clipper must be specially shielded to avoid being damaged by Jupiter's strong radiation. The same kind of shielding was also used with the spacecraft Juno in orbit around Jupiter right now. The Europa Clipper mission is meant to be launched sometime between 2023 and 2025 and is expected to take a minimum of 3 years to reach Europa. But we are still waiting on NASA to announce its choice of launch vehicle, which will determine the exact duration of the journey and the arrival date to Europa. Europa Clipper will not be the first mission to Europa, though. The European Space Agency, ESA, is actually going to beat NASA with a mission not only to Europa, but to Jupiter and all its icy moons, Ganymede, Callisto, and Europa. The mission is called JUICE, short for Jupiter Icy Moons Explorer, and it's also an orbiter spacecraft planned for a 2022 launch. NASA is also considering a possible Europa lander mission that would follow Europa Clipper. This lander mission concept would study the seismic activities of the moon and detect Europa quakes, as well as sample material from Europa's surface to be studied on site. But the lander would have to be designed so that it would sustain the incredible cold of Europa that ranges from minus 134.444 degrees Celsius, minus 210 degrees Fahrenheit, to minus 223.333 degrees Celsius, minus 370 degrees Fahrenheit. Let's hope all the future Europa missions best of luck. We're sure they would have made Galileo Galilei proud.